Hi everyone, I'm back with lesson 4. We're going to continue our probability, and today we're going to be talking a lot about events being independent or dependent. So when we studied yesterday, we talked a lot about the conditional. Today that is going to affect our idea of an event affecting another event, which is called dependence, okay? So just understand that in our study of probability, when you're talking about your conditional probability and determining whether one event has an impact on the other event, that's pretty much dependence. So two events A and B are independent if the occurrence of one event does not change the probability that the other event will happen. Okay, so that's really important. They're independent if the occurrence of one event does not change the probability that the other one is going to happen. So I guess before we really fully dive into independence and dependence, let's just kind of use basic events to help us figure out what the difference is. So are the following events independent, and explain? So the first flip of a coin is heads and the second flip of a coin is heads. Are these events independent? Yes, okay. These events are independent. They are totally independent of each other. And they're independent because no matter what, the probability of heads, because the probability of heads is always 1/2. So whether you flip that first one and you get heads and you flip it a second time and get heads or tails, it doesn't matter. Your probability of getting heads on that second flip is still going to be 1/2. Okay, so that's independent. Next one says you draw a king from a deck of cards, okay, without replacement. You draw another king. So let's just talk about this whole without replacement. It means you don't put it back. Without replacement is you're not putting it back. So will those events be independent of each other? No, these are going to be dependent. Okay? Your probability of picking that first king, okay, on the first pick is there's 4 out of 52, right? But on your second pick, you have to assume you picked that king and now you're holding it in your hands and you are not replacing it. Remember, without replacement is do not replace. You're not replacing it. That second pick now, you have a probability of, second pick has probability of 3 out of 51. And they are not equal. Okay, the probabilities are not equal, meaning they are dependent. Okay, so let's understand this little formula almost. Events A and B are independent if the probability of A given B equals the probability of A. So just take note. It's the first term matches. And then when I say it again, I could say, and the probability of B given A equals the probability of B. So once again, notice it's the first term, again, the first event. So in other words, B doesn't affect A and A doesn't affect B. If I say that the probability of A given B still equals the probability of A, then B did not affect the probability of A. reverse, if I say the probability of B given the probability of A still equals the probability of B, then A did not affect your outcome of that event B. So just understand this: when showing your independence, you do not need to show both. Pick one or the other. Doesn't matter which way you pick it, that will be able to prove that events are independent or not independent, dependent of each other, okay? So you do not have to show both. You could just pick one or the other. But very important, I just want you to once again take note that when you are showing it, when you're showing the probability of A given B, then you're going to be proving, is it equal to the probability of A? If you're doing the opposite, probability of B given A, then you have to look for it to equal the probability of B. Okay, so let's try one. Everybody go to number 2. Okay, number 2, it's giving you a survey of 57 sixth graders, and they're talking about their favorite subject, and they are breaking it down into male and female. So the first question is asking, find the probability that a student's favorite subject is math. Okay, so total math is 18. Probability, I guess I could write this. Let me go. Probability of math is 18 out of 57, right? Total number of people that love math is 18 out of the total of 57. Okay, find the probability that a student's favorite subject is math given they are a female. So here's yesterday. They now are saying, what's the probability of math given female? Okay, so what's the probability of math given you are a female? So remember this, your denominator is the number of females. How many females altogether? 30. Of those 30, how many were female? 8. How many people, I'm sorry, not were female. How many people liked math? 8. So 8 out of 30 is your conditional. Okay, now it says, are the events, math is their favorite, so that's like letter A, and female independent. Okay, so think about that formula from before. So if I want to say the probability of math given female, I'm going to ask myself, is it equal to, it has to be the probability of math. Now, you could have rewritten it the other way, the probability of female given math, but then you would have to do, is it equal to the probability of female? So I'm going to prove it this way. It doesn't matter which way you do it. Okay, so the probability of math, picking math as your favorite subject, given you are a female, was 8 out of 30, right? That was just from the last one. And the probability of just picking math as your favorite subject was 18 out of 57. Okay, so are these equal fractions? So I'm going to just pull up GeoGebra off to the side and do 8 divided by 30 and 18 over 57. Okay, so we could see they are not equivalent. We know that 8 out of 30 is 0.26, repeating, and 18/57 was 0.3157. So about what? 31.5 or 31.6% and 26.7%. Okay, so you are then going to be able to conclude these two events, I'm going to say they are not independent. And simply because the probability of math given female is not equal to the probability of math. Okay, so if those were to equal, they would be independent, but these are not independent because they are not equal. Okay, it's a lot to take in. Let's try another. Let's look at number 3. In number 3, we're talking about a survey, student body at Central High School about television viewing preferences. Okay, so the first question is saying, are the events student is a male, and student prefers a reality series independent of each other? Okay, so I'm going to do the probability of male given reality. Does that equal the probability of male? Now, once again, you could do the same thing by just saying the probability of reality given male. Does that equal the probability of reality? Same thing. You don't have to do it twice. You could pick one or the other. So now, the probability of male given reality. So of the reality, which is 180, how many were male? 70. So this is 70 over 180. Okay. Does that equal the probability of picking a male? Well, male were 230 out of 490. Okay. So let's go to the calculator and look at those probabilities. Okay, I have 70 divided by 180, which is about 0.38 repeating, and 230 divided by, I don't know why that just happened, 230 divided by, what was that, 490? Yeah, 490. Okay, so we could see that those are not equivalent. This one is, I'll just write it up here, 0.38 repeating is not equal to 0.469. It was something like that. So you are going to say they are not independent because their probabilities are not equal. Okay, that's all you have to prove. All right, they want us to prove another one. Are the events student is female and student prefers drama series independent of each other? Okay, so if I do the probability of female given drama, does that equal the probability of female? Okay, once again, you could do it the other way, doesn't matter. So probability of female given drama series. So of the drama series 135, how many were female? 70. 70 out of 135. Does that equal the probability of females? Females were 260 out of 490. Okay, so if I'm going back here, and I'm going to just get rid of this so it's just easier to see. 70 out of 135 is about 52%, and 260 out of 490, nope, is about 53%. Okay, so I'm going to show that. I'm going to show, nope, it'd be, wait, let me go back to this. 0.5185. So 0.5185, something like that, does not equal 0.530, I think it was 53. Okay, so they are not independent of each other. And actually, I really don't need to explain, being that you are justifying any of this that says justify your answer. Technically, this justification is the mathematics. Okay, so let's take a look at the next one. The only thing I would want to do with the next one, they're talking about gender and which hand you write with. And they're talking about a class is described by to a table. Okay, so Stuart wants to know, Stuart says that the events female and right-handed are independent. Okay, is he correct? So the only thing this is missing are totals. So I just want to total this and then total here. So total number of females is 21. Total number of males is 7. So 28 people altogether. There are 4 left-handed and 24 right-handed. Okay. So if I do the probability of female given they're right-handed, I need to know, does that equal the probability of a female? Okay, so given right-handed, so how many people are right-handed? 24. Of those, how many were female? Of the right-handed, how many were female? 18, so 18 out of 24. Does that equal the probability of female? Okay, how many female were there? Altogether, 21 females out of altogether there were 28. Okay, so if I check this, okay, and I go in here, I have 18 out of 24, 75%, and 21 out of 28, 75%. Okay, so here we go. So if this is 0.75 and this is 0.75, guess what? Finally, yes, they are independent of each other. They are independent. Okay, why are they independent? Because the probabilities are equal to each other. So I feel like right now is a really good time for me to prove the other way to you. What if somebody else had done the probability of right-handed given female? Well, then that has to equal the probability that you're right-handed. So if I say the probability of right-handed given female, how many females are there? There are 21 females. Out of that, how many are right-handed? 18. Does that equal the probability that you're right-handed? Well, how many right-handed? 24 out of 28. So those aren't the exact same fractions that we saw before, but let's just check. These should equal if we're doing this right. So is 18 out of 21, I didn't write 18. 18 out of 21 gives you approximately 8.85, about 85, 86%. Is that equivalent to 24 out of 28? Yup, jackpot. So it's about 0.857. So I just want you to see that 0.857 is equal to that same number, something like that, okay? So again, either way you do it, as long as you do it where your first, whatever you're trying to find the probability of, given something equals the probability of what you're trying to find the probability of. In other words, if I say the probability of right given they're female, I'm proving right because I'm trying to prove that female has no bearing on it, okay? They are independent of each other. Okay, I'm going to do one more with you. So let's talk about this one. This is saying the probability of a student at local high school, okay, passes the Algebra 2 exam is 0.9, and the probability of a student attending a review session to prepare for that exam is 0.8. That's the review session. The probability that a student attends the review session and passes the exam is 0.75. So the first question says, find the probability of a student passing the exam given they attended the review. Okay, so this is yesterday. The probability that they pass given they attended review. Okay, so we don't have a two-way table. If we had a two-way table, we could easily see those numbers. But here we're going to do the formula. If it's pass, given, review, then we have to do the probability of pass and, which looks like this, review, over, always the second one, the probability of review. Okay, remember, that's always in your denominator, that second one, given. Okay, so what's the probability that they attend the review and they pass? 0.75. And what's the probability that they just attended the review? That's 0.80. And if I divide 0.75 divided by 0.80, I get 0.9375. So there's your probability that a student passes given they attended, about almost 94%. Okay, the second part says, does attending the review affect the probability of passing your exam? Okay, so now we have to do an independence test. Does the probability of passing given review, well, that would mean it has to equal the probability that they pass, okay? Because then we're saying that the review had no bearing on passing. They are independent of each other. So the probability, we just did it, of passing given review was 0.9375. Is that equal to the probability that people passed? Well, what was the rate of them passing, the probability of them passing right here? 0.90. They're not equal, okay? They don't equal each other. It's not exact. So you would say, does attending the review affect? Yes. Yes. I would say the probability of passing given attending review is higher than the probability of passing. So clearly the review helped to pass, okay? A higher percentage passed given that they took the review. Okay, sweet, I'm up to the homework. So you guys are set. Hopefully you understand this. Please let me know if you don't. And that's it.